All right, quick lesson on how to name and draw carboxylic acids, really just focusing primarily on how to name it, because if you can name it, you know how to draw it. So carboxylic acids, what are they? A carboxylic acid is an organic compound that contains the carboxyl functional group, which is what is shown below. It's C double bond O and then also an OH on that carbon. So when we take a look at this, it actually is made up of two functional groups that together is called one functional group. So a carboxyl group is called that because it has both a carbonyl, which is a C double bond O, and then it also has a hydroxyl, like what you would see in alcohol. So when you have both of these together on the same carbon, we call that a carboxyl functional group. So that's a new one, and that's what we find in carboxylic acids. Now, you actually know about carboxylic acids. For example, vinegar, ethanoic acid, is a carboxylic acid. They're really quite simple to name. All we end up doing really is naming it by putting oic acid at the end of the name. So what we do first is we locate the longest continuous chain that contains a carboxyl group. So it has to contain that carboxyl group no matter what, even if it isn't the longest chain, it's the longest chain with the carboxyl group. Then we number, and we always start with the carboxyl group being the carbon number 1. So the carbon that is part of that carboxyl group, this carbon right here, that's carbon number 1. And so we never have to actually specify the location of the carboxyl group because of the fact that it is always number 1. And then from there, name branch positions and size of the branch is the same as in alkanes and organic halides and all that jazz. So we just kind of like name it, but the ending is going to be oic acid. So let's take a look at a few examples, go through it, and then we should be in good shape. Now, this is a really lazy condensed diagram because we just skipped doing the hydrogens entirely on this. So of course, on this one, there is 3 H's on this carbon, but we've just left it off completely, so we're not showing that. Don't let that confuse you. So if I take a look at this structure here, I have to number the longest chain. This is going to be carbon number 1 and carbon number 2. Because this is the carboxyl group carbon, it has to be carbon number 1. So because I have 2 carbons in my parent chain, it's going to be ethane, right? AN, because I don't have any bonds. And then it's a carboxylic acid. So because of the carboxyl group, I name it ethanoic, and then I put a space. This is the first time you've had a space in any name so far. So I actually have a legitimate space, and then I have acid. So ethanoic acid is the name of that one there. Taking a look at B, this has 1, 2, 3, 4, 5, 6 carbons. So again, this is carbon number 1, which actually makes naming these almost easier than a lot of other, because you don't have to find the order to number it, and you know the order that always the carboxyl group is the carbon number 1. So here I'm going right to left. So for this, I have a methyl group on carbon 3 and carbon 4. So I have 3, 4 dimethyl. Hexane, oic acid. So again, the AN is because I have all single bonds here, right? And then I have the oic acid because of that carboxyl group. And now I'm done, I'm set. All right, why don't you try out C and see how that goes? D is a weird one, but C, give it a try in your workbook and see if you have any success. So when I number this, it's going to be 1, 2, 3, 4, 5, and 6. So I have a hexanoic acid parent name. And then I have an ethyl group, a bromo group, and a methyl group. So the real thing about this is just making sure we get that on alphabetical order. So I'm going to start out with the bromo. So 4 bromo, because that's alphabetically first. Dash 4 ethyl. E is next after B. And then 2 methyl. And then I have the 6 carbons, so this is hexanoic acid. All right, Now, D is actually a bit of a weird one. We have a benzene here, and then we have this carbon coming off of the benzene. Now, I could not put a carboxyl group directly on one of the benzene carbons because benzene carbons already have 3 bonds when they start out, right? They've already got 3 bonds. So I don't have room for a double bond O and an OH coming off of a benzene carbon. So we actually give this kind of a special name because it is so common that when we have a carbon coming off of the benzene which has a carboxyl group on it, we call this benzoic acid. Right, benz because we have, benzene, and then oic because it's a carboxylic acid. So benzoic acid. So that's just kind of one to realize, to memorize, or whatever. If I had other groups coming off of here, like for example, if I had a methyl group right here, well then it would be 3-methyl benzoic acid, that kind of name. So pretty easy. That's it. So really, carboxylic acids are quite simple to name. Now, when it comes to polycarboxylic acids, you don't have to name these, but just realize this is a thing. We can actually have more than one carboxyl group that's located on a structure. And this is just kind of special. It's different. So for example, citric acid, the stuff that you find in citrus fruits or sour candy, actually has 3 different carboxyl groups on it. This is the structure, which is kind of neat. And then I have a hydroxyl over here as well on this carbon, but I've got these 3 carboxyl functional groups and then a hydroxyl. So kind of neat to see. Tartaric acid, kind of interesting as well, because I've got 2 hydroxyls and then I've got 2 carboxyls on that structure. But just neat that this is a thing, right? That we can have more than one carboxyl group on an organic structure. All right, that's it. Have a good rest of your day.